So yeah, before I begin, I'm author of the Generative Deep Learning book, as Sophia said, but I'm also co-founder of a company called Applied Data Science Partners. We're based in London, and we are hiring. So if anyone on the call is looking for work in London and is a data scientist or data engineer, AI engineer, anything technically related to AI, then please do send your CV over. We'd be happy to kind of take that into consideration when we're hiring. So just send it to myself at david@adsp.ai, and we can get back to you. So yeah, large language models. So I always start this presentation by saying, July 1969 was obviously one of the founding moments in our history as humankind. It showed that we were able to, for the first time, dominate our physical world like we'd never been able to do before by landing a human on the moon, showing absolute control over our understanding of how the physical laws of the universe work. And so it's around the same time, actually, that people were asking very big questions about intelligence, well, what it means to be intelligent, whether we can create systems to be intelligent. And a lot of this was obviously being driven by things like the space race and the idea that, well, if we can land a man on the moon, then think what we can do with the agents and robots and intelligent systems on our own planet. And it seemed very, very close. It seemed only years away that we would be able to develop systems that were as capable as the rockets that were putting people on different bodies in space, that we were just around the corner from a revolution in AI as well. But actually, there was nothing really farther from the truth. We were still very, very far away from the AI that we know and love today. And it was only really recently in maybe 2016, 2017, that people were really talking about AI that was almost as a new frontier of what we can achieve, technologically speaking. And one of the foundational moments was the AlphaGo paper, an AlphaGo system that was developed by Google DeepMind here in London. And this was a system that was remarkable for a few reasons. Firstly, it mastered the game of Go, which has, I believe, more board configurations than atoms in the universe, showing that not only can we build systems that were very capable in simpler games like chess, but that actually even an unimaginable number like the number of atoms in the universe is able to be understood and operated over by an AI-based system. And it was called Alien at the time by Lee Sedol, the opponent of AlphaGo, because he was seeing that this system was able to create ideas that he almost saw himself as human, and that it was almost impossible to believe that a human could come up with such creative and beautiful ideas over the board. And then, after this, we sort of started asking ourselves, well, how close are we to AGI, artificial general intelligence? Are we just around the corner from it? Because now we've got AlphaGo, and it's only a matter of time before that turns into AGI, or are we quite far away? And I think people realize we're quite far away still, because these systems are very narrow. They don't allow you to adapt the rules of the game and still deploy the same model and expect the same performance. They're not zero-shot learners. You can't just tell them to do a new task and they are good at it first time around. And so there needed to be a new injection of something. And we didn't know what that thing was really back in 2016. But when we start thinking about things like AGI, we start thinking about things like chatbots, such as portrayed in the film Her. And it was actually language and natural language that was the key to unlocking a lot of the ideas that we see today around systems that are being talked about as close to AGI. And specifically the model that we are obviously talking about here is the GPT model that has come out of OpenAI, where the T here stands for transformer and is talked about heavily in my book, but also is a general way of modeling natural language as a sequence of tokens that is more capable and more powerful than simpler ideas such as recurrent neural networks, LSTMs, GRUs, anything which kind of treats the sequence as something that requires a hidden state that you need to update and maintain. But instead of that hidden state, transformers adopt a different idea called attention. And it's this attention mechanism that allows the system to, at inference time, basically pay more attention to certain preceding words in the sequence than others, that gives it this incredible capability. It's actually, I think, a much simpler idea than the likes of LSTMs. If you see the diagram of the LSTM cell in my book, you will soon see there's a lot of complexity in there that seems kind of ridiculous now that we're looking at attention mechanisms are actually a lot simpler to understand, and actually a lot more human. I think the idea that we're sort of at the point at which we need to decide the next word, we decide previous words, how much attention do we want to pay to them in order to detect and predict the next word. So what's amazing is that at scale, this is enough to produce a model that shows signs of general intelligence. I think that's true to say. And when I say at scale, I really do mean at sort of an exponentially increasing scale. The early GPT models here were 100 million parameters big in 2018, maybe breaking the billion parameter by 2019. But now, with the likes of GPT-3, 175 billion, 3.5, which is rumored to be more, the Palm model of Google, which is at 500 billion, and now GPT-4, which is rumored to be of the 1 trillion plus mark, although actually recent reports say actually it may be an ensemble of smaller models. Nobody really knows except those in OpenAI. With this kind of scale, what we're seeing is that actually you just throw more compute and more data at these models, and they do just get progressively better and better. And by better, what we mean is that they are exhibiting what are called emergent capabilities. So these are capabilities that we wouldn't expect to necessarily see as part of the model as it's been trained, because it's simply trained to predict the next word. But actually, there are certain characteristics that come out of doing that process that are quite amazing. So things like information synthesis, being able to actually compose an image of maybe an ASCII art or something, understand code, reasoning, theory of mind, embodied interaction. These are all things that sure are embedded within text and within human written text, but we're not explicitly telling the LLM to learn how to do reasoning. It seems that just by understanding and having a model of natural language, that these things pop out as a sort of happy byproduct, if you like, of the training process. I just wanted to highlight here, this is a system that we've built as a demo in-house at Applied Data Science Partners called the Interactive Detective game. So feel free to go on and play this. It's just a simple web app that you can post your API key into from OpenAI, and it will generate you a little whodunit mystery on the fly. And you can ask questions to all of the different characters in the game. So it's a natural language driven RPG, if you like, where you play the role of the detective. So of course, with all of these, the game is completely open. There is no barriers on what you can ask the people in the game. You can get them to talk to each other if you want. You can ask them what their relationship is with other players in the game. And we know that this is all possible because of these emergent capabilities. GPT-4 has the ability, and GPT 3.5 actually, to withhold in its memory, in its context, the who did it, so who is the culprit, and maintain that state all the way through to the end of the game. So yeah, it's a cool little example that sort of demonstrates some of these emergent capabilities. I just want to highlight a few more examples that I've been quite excited about recently, just very quickly. So Cicero is the first of these. I think this was one of the early signals that we were getting that there's more to these language models than just language. This is a system that was developed by Meta to play a game called Diplomacy. And anyone who's played Diplomacy will know it's largely a text-driven game. You have to talk very deeply with your counterparts that you're playing with, both your allies and your enemies, in order to negotiate, cooperate, and coordinate. So it's a bit like Risk as a game, but there's a lot more discussion, and you have to submit your actions all at the same time. And then the negotiation obviously plays a big part in forming friendships and potentially bluffing. And what they showed is that they can train a large language model to do this very, very well. Cicero is an AI agent that plays the game of Diplomacy, and it comes in the top 10% of all players, even amongst those that are expert. So an absolutely amazing example of how you can embed a large language model into a wider system. So more of an agent-based, turn-taking, action-taking agent. And that was the first time that I thought, actually, there's more to this large language model stuff than just being good at producing blog posts, for example. Second example is from a paper called Generative Agents, Interactive Simulacra of Human Behavior. And for anyone who's played a 2D sim game, this will be sort of very familiar to you. This is basically a 2D sim game that they'd mocked up for the LLM to play. And the idea is that every character in this game is operated by a large language model. So all of the little agents walk around bumping into each other, and have the ability to converse with agents and share information. So each agent has its own memory store. It has its own ability to use tools within the environment. And through interactions, the researchers are able to demonstrate that information and knowledge could flood across the network just through conversation. And in fact, quite complex and detailed ideas were being shared amongst agents, and even exhibited things like misinformation, where one agent would say something to another agent, and then that was slightly misremembered, and it would be passed on incorrectly. And it was quite amazing to see how quite complex interactive behavior could emerge from the system. So, for example, one of the players decided to host a party, and then they would go around kind of inviting everyone to their party. And even another of the agents invited someone else on a date out to that party, and then that information spread through the network, and it was like a little society almost that was being created before our eyes. And they all took on different roles. So some were artists, some were authors. They formed opinions and had arguments. All of the things that you would expect in a human society were being shown to develop just by allowing agents in this world to be driven by large language models. So again, a real indicative and pivotal moment, I think, that showed the power of training things like GPT models. Now, a really interesting paper that you might have seen recently is this one called Sparks of Artificial General Intelligence that came out a few months ago. And it was showing basically how GPT-4 is already developing and exhibiting some forms of AGI, but that even more than that, if you give it the access to tools and other interfaces, that it can actually learn and understand how to use them to even enhance its ability that's inherent within the LLM. And a good example of this is large calculations, right? So GPT is not at all designed to do large multiplications in its head, so to speak. However, if you give it access to a calculator and say, look, instead of just doing this within your own language model, why don't you ask to use the calculator if you feel like you need to use it? And it does so. It just knows out of the box that a calculator in this tool would be a good thing to use to solve this particular problem. And so by providing these tools, the idea is that we can augment the large language model. And we use the LLM almost like as a general intelligence engine, in the same way that we would use a human as a general intelligence engine. And we wouldn't expect it to do things that are anti-human, like be able to multiply huge numbers together or run a Python prompt. These are things that you and I can't do without a computer. So it's almost augmenting the LLM to be able to give it these tools in order for it to solve more complex problems. And this leads on to the idea of LLM autonomous agents. This is a really good diagram, I think, that explains what we mean by that. It's where the LLM is just part of a wider system, and that it isn't everything, but it is almost the brain, the central point through which a lot of the other tools and memory stores and task lists and prioritization lists can operate. So, for example, you might set the LLM a general task, say to go out and do some marketing about a particular company. It would then break that down into a series of subtasks just using the LLM and save that to a memory store. And then it could spawn separate copies of itself or just continue with the same copy to either in parallel or sequentially solve those subtasks. And of course, there's a tree structure to all of this. So those subtasks might be broken down again. Some might be dead ends that don't lead to anything, in which case that information is saved to the database in its memory. It might decide at some point to use the web and do research through web browsers, or it might decide to use interactively APIs. As long as you give it access to these tools, it's quite capable of being able to go off and do different things. So AutoGPT is a good example of an autonomous AGI, or AI agent, I should say. It's one of the fastest growing open source repositories of all time. I think it's now got more stars than like PyTorch or TensorFlow. It's an absolutely remarkable example of what the open source community can build very, very quickly. And my last one is Voyager. So this is a really good example as well of an agent that is able to do something in a virtual world autonomously. Voyager is an agent that effectively can continuously explore the Minecraft world, and any skills that it learns, first of all by randomly exploring, but then of course by thinking more deeply about what it needs to do, are saved to a skills database. And what I mean by that is the agent has the ability to write Python code, right, to interact with the Minecraft world. So as soon as it finds a piece of Python code that's written is actually doing something useful, it just saves that Python code to a database. And so the next time it needs to use that ability, instead of having to use the LLM to write the code, it can just use the LLM to say, do I have any skills in my database that will allow me to do this? And if it says, yeah, you've got a skill here that allows you to turn, say, a block of wood into a pickaxe, then it will do that. And it's about this idea that the LLM is just a general intelligence engine that is tapped into a load of different other systems and memory stores that allow it to, over time, get better and incrementally more powerful within the environment that it's based. So a really highly impressive example. I'd highly recommend that you check out the paper for that one particularly. And so I just wanted to finish up really just by kind of summarizing my thinking around LLM agents and where they might go in future. There are opportunities and risks, I think, on both sides of the equation. There's no doubt about that. On the opportunity side, we're talking about being able to build agents that can solve problems very, very quickly and at a global scale, and even do things like scientific research, although there's a lot, I think there's a few steps that we need to put in place before that's possible. I think the second thing I'd like to mention as well is the ability for this to turbocharge education. Imagine if you were reading my book, but alongside that, there was a large language model that had been fine-tuned or even just placed into the context window of that LLM, my entire book, so that instead of having to jump onto this call and ask me questions, you could just ask the agent if there's anything that isn't understandable. That sort of thing is possible today. And I think there's products being built, as we speak, to really push that kind of application into the world. And yeah, obviously, like enhanced creativity and entertainment is a big area for generative AI, both on the text to image space, but also text to music, text to video. We're talking about already sort of Hollywood movies being able to be produced in 5 years' time just through AI. I think it's a really exciting time for the entertainment industry to see where they might take this technology. On the risk side, I think a lot of these come with sort of equal and opposite risks a lot of the time. So one of the big risks that people talk about is the risk of huge mass unemployment. There's a lot of reports from like McKinsey and those kind of big consultancies saying large parts of the workforce won't be needed as a result of AI. I think I hold a slightly more optimistic view than this. And I think I sort of see AI more as a tool than as a thing that's actually going to fully automate and replace a person's job. Although, as we've seen with, other technologies, there will be changes, I think, to the workforce, albeit not mass unemployment. People talk about the control problem as well. Is there a risk of AI and AGI running away and us not being in control? Again, I think it's an unlikely scenario, a very unlikely scenario, actually, but perhaps we can discuss that in more detail afterwards. And then there's obviously big questions around misinformation alignment. So this is where we're talking about the idea that, yes, we can build very powerful AIs, but do we know that they're aligned to our goals and our general ethics and what we would consider to be good behavior in the world? And lastly, dependency. Do we really want to become dependent on AI agents, or is there not something about the human condition that actually demands that we have a role to play in this world and we don't just farm off all of our responsibility to technology? So yeah, there's huge questions on both sides of this argument. And I'd sort of see myself as somewhere in the middle of this. I'm not particularly strongly opinionated one way or the other. I'm not an AI doom and gloomer, but also I don't think it will be a perfect utopia. So just to finish up, my last slide is one of my favorite quotes from JFK. He said this in 1962. This is 7 years before the moon landing. And he was talking about why we're doing this. Like, why are we bothering to build these systems that can go to the moon? And he encapsulated in this quote, I think, something really important, which is that humans love to solve hard problems. We don't do things that are easy. We do things that are hard. And I think AGI, we are effectively at the same point, I think, with AGI as sitting here today. It is almost like 1962, where we're sort of seeing that this stuff might end up being possible, but that we're going to have to face a ton of complexity and challenges before we see this kind of technology actually making a tangible and positive difference in the world. And so I can't wait to see before the end of this decade whether we reach true AGI. And I think it's possible, but we certainly need to be all aligned ourselves to work out what kind of future we want to create. So thank you. Thanks for your time listening, and happy to take any questions from any of you about that or about anything in the book.
That was so amazing. Thank you so much. I have a lot of questions about your slides and also about your book, but I would like to open up the floor to our book club members. If anyone has questions, please feel free to ask in the chat or just unmute yourself and ask directly.
One question I had is, what is AGI in your presentation? Like, yeah, what do you think it is? Because if you have a response, you can go ahead, but I can also provide more context.
No, it's a great question. I can give you my thoughts on that straight away. So when people talk about, first of all, AI, what I mean by AI is just a system that can solve problems. Now, typically AI has been narrow, so it's been a system that can solve one problem very, very well. AGI, I think there's no kind of one definition that I can give, but what I would say is that there is a sliding scale from an AI system that can solve one problem to an AI system that can solve any problem. Now, at some point along that line, I would say AGI occurs. And I don't have a kind of in my head an idea of exactly where that line is drawn, but certainly GPT-4 is further along that line than any system I've ever seen. However, and I don't mean this in a kind of flippant way, but it's not going to make me a cup of tea. And what I mean by that is I think GPT-4 is not at the moment tasked to make physical changes in the world. And that is, for me, a major component of what I would consider to be true AGI. It's going to be, I think, an overlap between AI and robotics, I think. And I do see it as really important in future that any system that we consider to be truly general intelligent will need to be able to make very significant changes in the real world. And I think this is where a lot of the danger comes in. As soon as we start giving systems that are intelligent access to tools that can make physical changes in the world, so not just kind of changes to a string of text, but actual, physical things that we can see, then that's where we need to start talking very, very seriously about regulation and control. So yeah, we're certainly further along the, let's say the kind of intangible problem solving, where it's not actually making a change in the physical world, but it's like solving something within the text string and within the context window, but that we're actually behind on a lot of other things like robotics. And we're seeing this with self-driving cars, right? The systems are trying to do something in the real world, and it's extremely difficult to reach that kind of level 5 self-driving.
Okay. So it seems to me it's like your definition is like the set of capabilities that a human can do. It's like once an AI can do all of those things, then it can solve all the problems we can, and it'll be like AGI.
Yeah, exactly. That's it. And I think like we don't give ourselves enough credit sometimes as humans for how much we can do,
Yeah,
like,
we're pretty dope.
yeah, we're awesome. And the AI systems are great, but we need to also give ourselves credit for what we can achieve over and above these systems, I think.
All right, thank you.
Thanks for the talk. Your slides were amazing. You talked about your definition of AGI. I mean, would you say that Shane Legg's definition, intelligence being the measure of an agent's ability to achieve goals in a wide range of environments, is it something that you also like agree with? And also, should we achieve AGI? Should AGI also be embodied in humanoids only? Is that when we can say that now we've achieved AGI, or should embodied in any other thing, let's say drones, or though you talked about cars, self-driving. There's that. And also my other question is on alignment. People from around the world have different values, right? You and I probably value different things. On alignment, we disagree on a lot. So are you in favor of, like, say, having like a body, a UN body and stuff that regulates and says, hey, these are the values everyone agrees to. So if we're building AI systems, we should achieve X, Y, and Z that everyone agrees to. That's on alignment. Yeah. Cheers.
Yeah, thanks. Thanks for the questions. So I'll take those one by one. So yeah, I'm broadly in line with that definition. I don't particularly, like semantics, I think, are kind of important, but also like I think generally people have an inherent understanding of what AGI will feel like when we see it. So yeah, the only thing I maybe would change to that definition is I think it's important that anything that we truly call AGI is robust to changes in environment. So it's not just about being very, very good at a diverse range of environments when you've been trained on a diverse range of environments. It's about the AGI system being able to adapt quickly to new changes and new tasks as well. And I think LLMs are particularly good at this because everything is done within the context window. So you can introduce an entirely new task in the context window. And because it's sort of, I guess the way of thinking about it is it's mapping any activity that you can give it into something consistent, which is a stream of tokens. And so the stream of tokens is the environment in which it operates. That is its world. That's why they're very, very powerful general learners. So yeah, that would be what I add to that. And then I think your second point there was around embodiment. Yeah, so I don't necessarily think humanoid, but I do think we need to be extremely cautious if we're allowing AI systems to make physical changes to the world. And what I mean by that is giving them access to tools that can cause us harm, like in a physical way, not just connecting them to tools that make API calls to another database or something. But I'm talking about like the ability for AGI systems to have access to, like you said, in the case of putting them into a drone, like that for me is extraordinarily dangerous and a bad idea. And I think this is where your third point comes in, which is the sort of regulation and ethics of this. And yeah, I do think that there will need to be some sort of body or at least governance that is agreed upon unilaterally that kind of talks about what we do want these systems to do and what we don't want them to do. In the same way, I suppose, we have things like human rights conventions, and we have sort of agreements about, war and what war looks like from a legal perspective between countries. And whilst no one obviously wants anything like this to happen, there needs to be some sort of broad agreement as to what's almost like what are the rules? What are we trying to all agree that this is at least a set of standards that we can all agree on? So I think it would be, these would be fairly broad. I don't think they would be particularly detailed. And you're right that everyone has a different sort of sense of what is right and what is wrong in the world, and alignment is going to be tricky between countries. But I do think there are ultimately a set of standards that we can all agree on that would prevent catastrophic failures in future. I don't think my personal view is we're not close to the kind of catastrophe that some would have us believe that we are close to. I think there's a lot of pieces missing. We've effectively built a system that can learn very well what the next token is in the sequence, and that's wonderful. And they are generalist learners, and they can do amazing things in the context window. But there's the technologies that we're using for things like memory, skill retrieval, the ability to prioritize and order tasks. These are old technologies. These are things we've had for years. There's no developments really being made there. Looking up of information is being done via cosine similarity still within most vector databases. So yeah, we've got one new technology on our hands, and it's important to remember that we've developed one thing, but it is awesome, but it's also like just one part of the puzzle. So yeah, I hope that answers your questions probably.
Yeah. Thanks.
Awesome. We got another question from the chat. What are your insights on the ethical implications open source LLM/diffusion models? For example, I'm thinking about stable diffusion that has been mostly ignored by the community, even though it tried to solve the previous version's ethical concerns.
Yeah, so kind of summarize and I guess steelman the side for both sides of this argument. The open source community would say, look, in order to solve these problems that we're having with things like training data not being particularly open, and the fact that any problems with the model are being owned by a very, very small group of people and trying to be solved by a small group of people, why don't we just release them into the world, and we'll be able to tackle the problems a lot more efficiently if there's more eyes on it. And that's the one side. And then I guess the opposite view to that would be, well, if you don't really want these models getting into the hands of very powerful people with nefarious actions and nefarious morals. So yeah, I kind of, my own view on this is I suppose I fall slightly down more on side of the open sourcing of things, because I think technology technology, especially AI technology, we're not talking about something like nuclear weapons, where the actual starting to get to get actually started with a nuclear weapon is actually, there's a huge kind of barrier to entry for most people. So I feel AI technology is something that we can't close off to people. People will find ways to learn about AI technology and how to build models like this, whether or not they're behind OpenAI's doors or not. I mean, people move jobs, people like talk to other people, people write blog posts. It's just not the way that tech has ever been done, I think, to sort of say, look, we've got this new software and we're not going to tell anyone how it works. I think the open source community is incredibly quick, and they will find ways to produce similar technologies, and in some ways, if not better. We're starting to see this with large language models, where they were initially kind of, I guess, open, and OpenAI were very clear about how they were building their models. And then suddenly it all went behind closed doors with the GPT-3 weights not really being released, and then even more on 3.5 and 4, the whole training process and methodology wasn't even released. And yet now we have commercial models like Falcon and MPT and the Llama sort of lineage of models that are not quite as capable, but certainly catching up to the likes of the most powerful GPT-4 models. So yeah, I don't think the argument of sort of just trying to keep it in a box is a particularly strong one.
So, okay, I had a question about like, making stuff. So, as you know, like OpenAI just released like the function calling stuff,
Mm-hmm.
but LangChain does this. And we were talking about building autonomous agents. I myself am like a founder, so I'm choosing a tech stack and betting on it, right? So, what's your view on like that situation? Because the fear is like the library is going to break down, or like the community is going to dissolve or something, right? So I'd just love your thoughts on that.
Yeah, another great question. I'm a founder as well, so we're sort of facing the same things with our clients, and where they're coming to us and saying like, do I bet on OpenAI, or is it Microsoft Azure and everything's going to be just in there soon? Like, do I host everything in house because I don't want the data moving anywhere? Like, they're big questions for companies. What I would say is, first of all, just build everything as modular as possible. So if the worst comes to the worst and the community breaks down, I don't think it will, by the way, the LangChain, I think there's a real use case for it. Then like, yeah, you'd have to pivot away from it and find other ways to kind of, leverage the same technology within commercial offerings, proprietary offerings. But I don't think that's going to happen. There's a very thriving community, and I think, they're talking about stuff like, investment and like, yeah, almost like setting up as a proper company and stuff. So yeah, there's no way that I can see that happening. But yeah, I do think like Microsoft and OpenAI seem to be fairly ahead. Although we're hearing from DeepMind they're going to release like Gemini model next week, and that's going to be even more awesome than ChatGPT. And so yeah, when I hear this stuff, I just think like, build everything modular. Don't try and like build anything around a particular engine, but just think to yourself, how can I modularize this bit of the solution so that ultimately it's just an input and output machine, and I can click in any LLM that I want in future. Yeah, I mean, that's my only advice, I would say.
Yeah, it makes sense. Thanks.
Awesome. Since we all have read the book for our book club members, let's change gear a little bit to talk about your book. But for viewers who have not read the book, would you mind give a brief introduction about the book and tell them why they should read the book?
Yeah, sure. Here it is. This is the book. Sorry, it's a bit blurred. Yeah, blurred background, but you get the gist. It's a book. It's quite meaty. It's much meatier than the first edition. So the first edition I wrote in 2019, before the world had heard of LLMs, and like, it wasn't a big concept. Like, people were talking about it, but it was still fairly niche. And I came to the second edition like last year, when I was starting to write, about this time last year actually. And so again, this is before ChatGPT. This is before DALL-E 2 had just been released actually, but it was before Stable Diffusion. And I thought to myself like, oh, that's cool. There's a few new things to write about, and maybe I can sort of get away with just updating a few chapters. And yeah, just freshening it up with new examples. And then like everything exploded, and suddenly the whole world was talking about generative AI. And I think I realized I needed to rewrite the whole book. There's just so many topics and so many things that were true in 2019 that now it's been blown out the water. And so the whole book is rewritten, I think, from the ground up to be what I hope is a true reflection of the generative AI landscape as I was seeing it unfold before me. So in 2022, but then also into early 2023. And what I've also tried to do is not make it aligned to any one particular model type. Like you could write a whole book about transformers, and people do. You could write a whole book about diffusion models or Gans. But I think what the last few years has taught us is that we don't know where the next big idea is coming from. If you'd have talked to people in 2017 or even 2018, 2019, they'd have still been talking about like building bigger and bigger GANs. And there's tons of books out there that are written about GANs that now look like, well, we've got diffusion models now. And even the advanced GANs are kind of using ideas from other kind of fields like transformers. So I think what this book hopefully does is give you absolutely the groundwork that you need to understand any kind of generative AI model. And it doesn't try to push you into one sort of direction and believe that transformers are everything or GANs are everything or diffusion models are everything you need to know. But to keep an open mind, it talks about kinds of model that I haven't really seen written about elsewhere, like normalizing flows, energy-based models, which is what Jan LeCun is very, very keen on exploring at Meta within his like JEPA architectures and stuff. So like the next big idea might come from energy-based models, and suddenly we won't be talking about transformers anymore, or we won't be talking about diffusion models. And so yeah, if you want a general sort of foundational understanding, I think I hope that what I've written is the book that you need to get that.
Awesome, that's really helpful. Thank you. We got a hand raised earlier. Would you like to ask your question now?
I think he answered it because I wanted to ask, you concentrated heavily, not heavily, but I saw compared to your previous book, the introduction of transformers. So I just wanted to ask, like, you see the field converging towards language and transformers especially. But I guess you answered it, talking about just don't concentrate on one particular model because you don't know what will happen tomorrow. Something else might come and upend transformers and all. But all in all, I just wanted to ask you, what do you see with transformers at the moment? I mean, they're doing pretty well in lots of things, even vision. Surprised with the vision transformers. What do you see the future of transformers themselves?
Yeah, you're right. They are being used in different modalities, not just text, vision, even video. I was seeing the other day. I think the general idea that you can treat a lot of kinds of data as a stream of tokens is quite a powerful idea, which is why transformers have done so well. I think with transformers, the important thing to kind of keep on top of is like what are the different components that are being clicked together within the transformer to make them work. And a good example of this is attention. You can learn about attention from my book and from other resources, and that will give you a base understanding of what attention is and what it does. But then it's like the branch of it or the trunk of a tree. You then need to kind of explore, well, what other stuff is being done today that builds on the idea of attention. So there's things like flash attention, for example, that are used in a lot of the state-of-the-art models these days, that give the attention layer, first of all, the ability to be much more memory efficient, and also the training process to be more efficient and faster, but to maintain the ability for it to be very powerful. So what I guess you're not going to get from any single book is a complete overview of every single tiny like paper that's ever written about attention. But what you can get from the book is what attention is, what it can do, why we're using it, why it's better than recurrent neural networks, and so on, so that you can then read a paper that is advanced, like the flash attention paper, and at least understand what it's talking about when it's talking about keys, queries, values, embedding dimensions, and all this kind of thing. So yeah, I mean, where I see transformers going is that, yeah, I think they will probably end up getting bigger, but also I'm excited about the idea of it being a type of model that you can use in a more sort of ensembled way. So I think that it'd be really interesting to see how GPT-4, when the paper, if they ever release the model information, whether it is just an ensemble of smaller transformers, or whether it is this one giant transformer that tries to learn everything. So yeah, I would say just to kind of, keep on top of these little add-ons, if you like, to the base model. LoRa is another one, LORA, low rank adaptation, which is again the ability to fine-tune transformers in a much more efficient way. And quantization. There's a ton of little kind of subfields that come off the main branch of transformers.
Yeah, appreciate your reply. Thanks.
You mentioned the transformers will get bigger and bigger, but also in the book you said the models will get more and more efficient and smaller. So do you think it will get bigger or get smaller?
Yeah, great question. I could go either way. I've probably given both opinions at some point. I think if you look historically, what's happened is that the model size has kind of stagnated, because in 2020 we had GPT-3, which was 175 billion parameters, and people were already saying, oh, in 2021 they're going to be at 1 trillion. Because if you look at that curve from 2018, which was 100 million, through to 175 million in 2020, like 2023 we should be up in like the multi-trillions if you follow that curve. But we're not. We're still being talked. A lot of models are still bouncing around the 175 billion parameter model. Falcon, for example, the open source one, is 40 billion. GPT-4 is rumored to be 1 trillion, but might just be an ensemble of smaller models. So when I say they get bigger, what I mean is I suppose they'll get more efficient with the number of parameters that they are using. So they might get bigger in capability, but they might stay the same size, or if not smaller, in actual parameter count. And that's because ultimately, if you're going to deploy these models, they have to be highly parallelized. They have to be really quick at inference. So you can't just keep adding more and more parameters without a knock-on effect for things like inference time. So I think, yeah, they might get better, they might get bigger, but they also might just sort of become more efficient using the number of parameters that they've got.
Right. And maybe use different types of hardware even.
Yeah, there's a lot of chips now being built that are specifically designed for kind of the matrix multiplication that goes on within transformers, for sure.
Very cool. I have a kind of a specific question. Like the chapter 10, a lot of our book club members find it hard to understand advanced gangs. I wonder if you could talk a little bit about like pro gang, style gang, VQ gang, and other models mentioned in the chapter, just high level, and which of those are the most state-of-the-art models. And you mentioned Stable Diffusion is ample form, the state-of-the-art gangs. So it doesn't mean like we don't really need to learn about them.
Yeah, that's a great question. I've had questions about this before as well. People say, why are you even writing about GANs at all? Because isn't it all about diffusion models now, and so on? And I think there's two reasons and two answers to the question as to why they're in there. First of all, they certainly add to the history and the richness of the field. And I think it's important to recognize that still a lot of the state-of-the-art benchmarks are still held by GANs. Like StyleGAN XL, for example, is a absolutely state-of-the-art model for image generation. And also the second thing to recognize is that even within so-called non-GAN architectures, a lot of ideas from GANs are still being used. So to give a concrete example, the idea of having a discriminator that can try to detect whether something is real or fake is still being used within things like vision transformers. There is a component to, for example, the model type called VQ-GAN and VQ-VAE that is still driving things like DALI 2. And so like a lot of state-of-the-art sure is diffusion models, but actually they borrow ideas from GANs quite heavily. And so it's important first of all to recognize historically the significance of the GAN, but also like the core concepts are still very much relevant today. In terms of like that specific chapter, I think what I wanted to do is give a little flavor, almost like like one of those meals that you get where you get a little bit of lots of different things, of a few different state-of-the-art architectures, and to show you that lineage from, like, we've just done a whole chapter on how to build a GAN, and now here's what state-of-the-art looks like. And to show like it's often small tweaks to the underlying architecture that make a huge difference. So even if it's not completely 100% clear, how mathematically something works, To take, for example, style gain as an example, the ability to kind of inject that style vector into different layers of the GAN is what gives it the power of being able to be able to, just adjust the hairs on somebody's head compared to the entire way in which they're looking, left or right. And it depends at which point you inject that style as to where the style gets represented. Is it at the high level or is it at the low level? And we're starting to see ideas like that in diffusion models as well, where in Midjourney now there's a kind of very subtle and very significant or something like that button, where the diffusion process is kind of stopped after a certain point, and then the style that you want to add is injected at that point, or you can stop it the process much earlier and inject the style higher up the diffusion chain. So yeah, it's about sort of recognizing the links between different ideas. I think it's true to say a lot of the best ideas ever come from a crossover between different fields. It's people talking to each other who've studied GANs really heavily, talking to people who've studied diffusion really heavily, where a whole new idea might come up that no one would have thought of on their own. So yeah, it's good to have a general understanding, I think, of every field, including GANs and diffusion models and everything else.
That's really helpful. Thank you. We have another question from the book club earlier about the music application, which I find just fascinating, because before I thought music, isn't that just text? But then when I read about your chapters, like it's totally different, so much more complex, right? You mentioned the method of combining notes and duration tokens separately. You mentioned about how to do phonic music. There are two methods, grid tokenization and also the event-based tokenization, and also like MuseGang is so fascinating. You're trading piano roll as picture. Yeah, so those are really fascinating to me. The question is kind of funny. We have a question about, do you play instruments? Do you think it's important to understand music theory to be able to make music applications?
Yeah, great question. I do play an instrument. I play the cello. So I've always played the cello my whole life, as long as I remember, from about 8 years old. And I think, when I was working out what I wanted to do as a kid, it was always going to be something in AI or something in music. So yeah, I chose the AI route because it's very, very hard work to be a professional musician. I have a lot of respect for people who do that. So yeah, I love going to concerts, and orchestral music is one of my favorite things, concertos and so on. But to be given the opportunity to talk and write about the intersection of those two things is really exciting for me, which is why I wrote a whole chapter about it, because I wanted it to be quite a significant part of the book. And yeah, the ways in which, so first of all, I think it's important to note music generation lags behind on the scale of AI development behind something like LLMs and text-based generation, because first of all, there's a ton of language out there to train on. So we've already got the training data. There's not as much music, I think, out there to be able to be pulled into the models. But also, I think music is a lot harder. And you think about language generation, it's tokens of integers effectively that you're looking to generate. Most languages, certainly English, is non-tonal. So if you're trying to create English spoken text through an audio file or something, it's a lot easier than than some of the more tonal languages like Mandarin, for example. But then also, I think if we're looking at music itself, there's so much nuance to that sound as to how it makes us feel emotively that you don't necessarily get in text. Text is more about grammar, rules, and when you listen to a piece of music, I think you can quite quickly understand why this is so complex to generate, because whilst there's not as much grammar to learn, I think the complexity of music comes from the subtlety in how it's interpreted by the listener. And it seems that quite amazingly, two people can kind of listen to the same piece of music and get something completely different out of it. So it must be even harder for an AI to understand what makes sense musically and what doesn't make sense. So yeah, I know there's companies kind of working on this actively. There's Harman AI, that's an offshoot of Stability AI. They're working actively on the music generation problem. Obviously, Google with Music LM that was released recently. I know Meta have just released a spoken voice. I think it's called something like Vocalize or something like that. Really interesting as well. That's more to do with human audio human spoken generation. but yeah, in the book, again, we just go through the fundamentals of what kind of problem we're trying to solve here. It's still a sequence prediction problem, but note duration obviously has a big role to play. As in text, I can speak very, very slowly or very, very quickly, and the meaning is the same. But in music, it isn't that case. It isn't the case. And you also have pitch as well. So I can speak very, very high or very, very low. And again, the meaning is exactly the same. But in music, those two things are completely different. So there's a whole 2 extra dimensions there that you don't have to worry about, I guess, if you're just dealing with text generation.
Right. It's amazing that it's lagging behind. I'm just curious to see what would happen next, because the method you mentioned seems pretty advanced.
Yeah, I think you think about it, a lot of music generation is solvable now. So like if you're just doing a jingle for an advert or something, or something that's like got a drum track and there's maybe a tune over the top of it, that sort of music, I think we can safely say is not solved, but at least on the way to being solved. The question is whether you could get an AI system to write a whole symphony with multiple movements and ideas from the first movement of that symphony, recapitulated in the last movement, or to have different sort of tones and emotions that are captured within that piece of music that mean something. I don't know. We're certainly not there yet. It's the same idea, I guess, as writing a novel, isn't it? It's very different to write a piece of copy for your website or a blog post or a tweet than it is to write the entire Harry Potter series and all of the ideas and the consistency across those 7 books, or Lord of the Rings or whatever. These epic works of literature seem completely alien to certainly to me. I could never imagine being able to hold that amount of information in my head and produce such a consistent and wonderful work. And it'll be interesting to see whether and if we can get AI systems to do the same, or whether we'll always be able to say it's not quite as good.
Yeah, makes sense. We got 3 minutes. Anyone have one last question? So we can ask one last question. No? Okay, I'll go ahead then. So there are a lot of startups in the space, and every enterprise wanting to have a piece of pie on this. But I feel like a lot of the ideas are not valuable. What kind of applications or ideas do you think are actually valuable in this space?
Okay, I would say, there's low-hanging fruit for sure. Like the low-hanging fruit is, can I respond to my customer service inquiries faster? Can I write copy quicker when a new product comes onto my website? Can I talk to my documents in ways that I haven't been able to do before? So instead of me having to read a book or a paper and sort of just sit there and wonder, why did they mean this? Why didn't they say this? I could just ask the document. So there's kind of low-hanging fruit like that. I think the next level beyond this is things like using AI within education. So to form kind of personalized learning experiences for every student, where they can ask an assistant or an agent to help them with a particular thing that they're not understanding. That feels like slightly more valuable and also more complex to me, to maintain kind of consistency over time, to come up with personalized learning pathways and plans for, putting together a test just that was tailored to you. And so that you can enhance your understanding. I mean, I'm trying to learn German at the moment, and I'd love something like that to kind of every day just give me exactly the 50 things or 20 things, let's say, that I need to, little 20 questions that I can right at the limit of what I'm capable of learning. There's nothing really out there that does that at the moment, not well anyway. So that's another angle. And then the third, where is this perhaps going in the future? I would say the agent-based LLMs are, I think, the most exciting thing I've seen for a long time in technology. And there's problems with this at the moment. I mean, even AutoGPT, it's got like 150,000 stars or something, and yet I've yet to see a real sort of absolutely killer app that someone's built using AutoGPT. And I think the reason for that isn't because the idea isn't good. I think the idea is fantastic, but it's complex and it's really difficult to get these agents to kind of maintain consistency over time. They are ultimately, it's like, we're here and they're trying to find a trajectory to over here somewhere. It's very easy to miss. And it's about how do we give them that kind of human oversight of sort of stepping back and saying, hang on, I'm off track here. like I'm not solving this problem at the moment. So there might be ideas, something like reinforcement learning that are being built in. Also, I'm excited to see DeepMind's Gemini, that they've sort of rumored to be incredible and use ideas from AlphaGo. Yeah, there's a lot more to come, I think, but they're the sort of 3 stages I would bucket things into: the low-hanging fruit, and then actual practical personalized applications such as in education, and then maybe agent-based LLMs in future.
Love it, love it. Thank you so much. We're at time. Really appreciated our conversation. It was such a great learning experience. Thank you so much for the book and the conversation. Yeah,
You're very welcome. Thank you.
I'll post the videos and I will send you the link.
Great. And I just, the last thing I'd say, if it's okay, thank you first of all for having me. It's been an absolute pleasure talking to you all. If anyone fancies leaving a review on Amazon, I would love you to do so. It really helps. First of all, just for me to get feedback, but also just helps with like other people wanting to understand what the book is and what they can expect. I would love it if you could leave a review, and I'd be really appreciative of that. So thank you.
Yes, will do. Thank you so much. Bye.
Thanks, everyone.
Bye, everyone.
Bye. Nice to talk to you. Bye.